Hi students, in previous video lecture we have seen the distillation of miscible liquids, in which we have seen theory of distillation of miscible liquid pairs of type 1 and type 2. In type 1 we have seen the theory of distillation of type 1 liquid, in which the total vapor pressure or system possessing intermediate total vapor pressure or system which boils regularly or whose boiling point increases regularly. In that part we have seen, or we come to know, that if you want to distill the liquid mixture of two volatile components by simple distillation process, then in order to obtain pure component we have to distill in repeatedly distillation, condensation, distillation, condensation. That means we have to distill several times repeatedly that particular mixture, then and then only we will get the pure components. But to avoid this tedious process, we have the option for that, and therefore if we perform fractional distillation of this particular mixture, then in one run we can obtain the pure components, one in a residual solution and another in a condensate, and therefore by performing partial distillation we can achieve such a type of separation. The type 2 that we have seen, that is total vapor pressure maximum in the total vapor pressure or system in which boiling point is minimum. And now in this lecture we are going to see the third type miscible liquid mixture or miscible liquid pair, that is minimum in the total vapor pressure, that is maximum in the boiling point, that is system in which boiling point is maximum. Boiling point is maximum. Now to study this particular system, here we have the boiling point composition diagram of this particular system A, B. Now this is A, B, and this is composition C. This is vapor composition, this is liquid composition. Now if you consider any composition of this side, that is suppose X, and if we take this composition in a distillation flask, then if we heat that composition, then temperature increases, and at this particular temperature, suppose T1, this liquid mixture starts boiling. Vapor coming off will have composition this, and if you condense these vapors, condensate will have composition X dash. Now in this condensate, the component A become in a richer proportion, and in residual solution component B become in a richer proportion, and therefore the composition of residual solution shifted towards right hand side, and the new composition, suppose that Y, if we shift that particular composition, then that composition will start boiling at this particular temperature T2, and vapor coming off will have composition this, and if we condense these vapors, condensate will have composition Y dash. On continuous heating, the composition continuously changes, composition of residual solution continuously changes, and therefore boiling point of solution also continuously changes. Now here the composition of residual changes shifted towards right hand side, and finally reach to a point, this point C, and final residual solution will be the azeotropic mixture. That means composition C, azeotropic mixture, composition C. Now, if we consider this particular composition C in a distillation flask, and if we shift that composition, then what will happen? Here condensate will be the same composition. That means this solution distills off completely without change in composition. That means whatever residual solution we have taken in this particular distillation flask, it will completely distill without change in composition into condensate. And therefore, this solution or this mixture is called as azeotropic mixture or constant boiling mixture. Now, if you consider condensate of this first stage, that is X dash, and if we take that condensate in a distillation flask, then it will boil at this particular temperature T1 dash. Vapor coming off will have composition this, and if we condense these vapors, condensate will have this particular composition. If we take this condensate again in a distillation flask and if it that condensate, then it will boil at this particular temperature, and vapors coming off will have composition this, and if we condense these vapors, condensate will have composition X3 double dash, X3 triple dash, and thus on repeated condensation and distillation, final condensate will be the pure component A. That means if we consider any composition in this site and if we distill that particular composition, then and if we perform fractional distillation of this particular composition, then the condensate will be pure component A and residual solution will be the azeotropic mixture. Azeotropic mixture. Now here, if you consider any composition in this site, that means if suppose we consider this particular composition, suppose M, if we heat that composition in a distillation flask, then what will happen? Temperature increases, and here at this particular temperature, suppose it is T3, this mixture will boil, vapor coming off will have composition this, and if we condense these vapors, condensate will have composition M dash. Condensate will have composition M dash. Now composition of residual solution shifted towards left hand side. That means composition of residual solution changes, and again if you consider this particular composition, suppose this is N, and if hit that composition, then it will boil at this particular temperature, that is T4, and vapor coming off will have composition this, and if we condense these vapors, the condensation will have composition N dash. And on continuous heating, the composition of residual solution changes. As composition of residual solution changes, the boiling point also changes, and therefore on continuous heating, the composition shifted towards left hand side, and finally we will obtain the azeotropic mixture, that is of composition C. The same feature of that particular, if we distill this particular mixture, azeotropic mixture, then it will distill up completely without change in composition. That means whatever in distillation flask, entire will be in a condensate. Now again same, if we consider the condensate, that is M dash of first stage, and if we consider that condensate in a distillation flask and if you heat that distillation condensate, then what will happen? It will, its temperature increases, it will boil at this particular temperature, suppose T3 dash. Vapor coming out will have this composition, and if we condense these vapors, condensate will have composition M3 double dash. Again, if we consider this condensate in a distillation flask and if we heat that condensate, then it will boil at this particular temperature, and again vapor coming out will have this particular composition M4 double dash, and so on. That means on repeated distillation, condensation, distillation, condensation, distillation, condensation, final condensate will be the pure component B. Pure component B. Now if we perform the fractional distillation of any composition of this site, then what will happen? The condensate will be pure component B and residual solution will be azeotropic mixture. That means in one run we can separate one component and azeotropic mixture. Now this azeotropic mixture is a constant boiling mixture. It distills up completely without change in composition. Now for example, we have the HCl water system of this type. Now here azeotropic mixture of this particular type is 20.24% HCl and 79.76% water, and this mixture will boil at 383 K. That means above the boiling point of both these components, this mixture boil at 383 K and forms the azeotropic mixture of this particular composition. That is 20.24% of HCl and 79.76% of water. If you consider any composition above this, that means above this particular composition, that means 79.76. If you consider 79.6 water above 79.76, then what will happen? If we distill that particular process in that particular mixture in a fractional distillation, then what will happen? Above whatever water above this 79.26% will separate out and again form the azeotropic mixture. That means only water above this 79.76 will be distilled and remaining as a azeotropic mixture. That means azeotropic mixture cannot be further separated by distillation. This is about the system in which boiling point is maximum of type 3 of miscible liquid system. In next part or in next lecture, we will see the distillation of partially miscible liquids or solubility of partially miscible liquid pairs. What it is, we will see next time. Thank you.